All right, so welcome to Scholars and Associates. Today, would like to look at cash flow under the financial mathematics. Cash flow under financial mathematics, which is under business mathematics. So what is a cash flow? A cash flow shows the inflows and outflows of funds. It basically shows the inflows and the outflows of funds, where the inflows are the monies coming into the entity or the business, and then the outflows are the monies that are going out of the business, right? So that is basically what the cash flow is. So the focus will be on the types of cash flows, because we have already discussed with details what the cash flow entails. So the focus would be on the types of cash flows. Types of cash flows. So one, we can talk of the annuities. The annuities or the uniform cash flow. The uniform cash flows. All right. So what is the annuities or the uniform cash flow? This is where the equal amounts are paid or received within equal intervals. So this is where equal amounts are paid or received within equal intervals. Within equal intervals over a period of time. Over a period of time, right? So if you have a susu boss and every month or every year you keep a specific amount of money inside, let's say every month you keep 200 cedis every month 200 cedis, 200 cedis, 200 cedis up to the end of the period. That is annuity or a uniform cash flow. That is annuity or a uniform cash flow. Keeping a specific amount into a fund over a specific period of time, right? So once the amount changes, then it ceases to be a uniform cash flow or annuity. So let's say you have a period 12 months, then you have been keeping 200 cedis from in the first month, 200 cedis, 200 cedis up to the 8th month. Now the ninth month, you saved 300 cedis instead of 200 cedis. From the 9th month, it ceases to be annuity. Why? Because the cash flow has changed. The amount has changed from 200 cedis to 300 cedis. So annuity must be a uniform, specific amount over equal intervals, right? Specific amounts, 200 cedis, 200 cedis. If once it changes along the line, it ceases to be annuity. It ceases to be what? Annuity. So there are two types of annuity. There are two types. So what are they? We have one, the annuity ordinary. Annuity ordinary. And then annuity due or advance. annuity due or annuity advance. So what is the ordinary talking about? So the annuity ordinary is when equal amounts are paid or received at the end of the period, right? So when equal amounts are paid or received. So here, paid or received means either you are paying it or you are receiving it, right? So that is the ordinary annuity. So equal amounts are paid or received at the end of a period. So here the key word is at the end. So the end, that makes it ordinary annuity at the end of the period, at the end of the words period, at the end of the period. Good. So now let's go to the annuity due or the annuity advance. Annuity due or the advance. Annuity advance. Here, this is where equal amounts are paid or received at the beginning. At the beginning of what? Of a period. Equal amounts are paid or received at the beginning of what? Of a period. So here it is at the beginning. That is the key thing that makes annuity advance different from annuity ordinary. Annuity ordinary is at the end, whereas annuity due or annuity advance is at the beginning. Equal amounts are paid or received at the beginning. So take note of the two. That is the difference between the two. All right, so now let's look at some formulas under each of them. Some formulas under each of them. So we have the present value and then the future values, right? As we discussed earlier. So the present value of annuity. Note that we said that present value, what we discussed earlier was the present value of a single amount. So we said the present value of a single amount is the future value over the 1 plus I exponent n. This is present value of a single amount. Right? And we also said that the future value is the present value over 1 plus I exponent n. This is also for a single amount. Right? Okay. So now we want to know the present value of annuity. Annuity. What is the present value of annuity? So the present value of annuity, we are going to look at the annuity ordinary and the annuity due or the annuity advance. So the present value of annuity is the equal cash flow over the interest multiplying 1 plus I exponent n minus 1 all over 1 plus I exponent n, bracket close. This is the ordinary annuity, ordinary annuity or annuity at the end, right? Remember, it's at the end. That is the ordinary annuity. For the same present value, looking at annuity due or annuity advance, that is the same A over the I, then 1 plus I n minus 1 all over 1 plus I exponent n, bracket close. Into bracket 1 plus I. So this makes the difference. This makes the difference. Let me even use red pen. This makes the difference. Into bracket 1. Wow. So 1 plus what? I. 1 plus I. Right? 1 plus I. So with the ordinary annuity, with the annuity at the end, or the annuity due, or the annuity advance, that one you are earning interest on the investment. So annuity in advance is at the beginning. Annuity due or advance is at the beginning, right? If you are making an investment, let's say someone invested at the beginning of January 2025, to begin in January 2025, and you invested December 2025, who is likely or who would be earning interest in 2025? It is the one that invested in January, because he invested in January, so he's going to earn interest for the January period. Because from January, February, March, April, May, June, July, August, September to December, he's going to earn interest for that year. But you that invested in December 2025, are you going to earn interest in 2025? No. You start earning interest in the following year, which is 2026. Right? You start earning interest in 2026. Because you invested at the beginning of the period, at the end. Sorry, you invested at the end, December 2025. So you start earning interest the following year. But the one that invested at the beginning will start earning interest at the beginning. That is why the present value for the annuity in advance or that beginning has 1 plus I attached to the formula, because it invested at the beginning. So the 1 plus I is taking care of the interest at the beginning. But the one that invested at the end is just taking care of it's just having the formula as we have A over I, 1 plus I exponent this, right? So that is this. Right? So the key difference between the ordinary and the due or the advance is the 1 plus I, the same formula, but only I'm talking about the present value. Right? That is it. So now let's quickly move to the future value as well. The future value. All right. So with the future value of annuity. With the future value of annuity, we have the future value is equal to what? The equal payment over I, to bracket 1 plus I exponent n minus 1, just like that. Right? So this is for the ordinary annuity. And then we have the future value is equal to A over I, 1 plus I n minus 1, n minus 1 then bracket 1 plus I, which is at the at the beginning, which is the annuity due or advance, and that is at the beginning, and this is at the end. So you can see that the only difference between the formulas is that the 1 plus I is attached to the beginning one, right? Whilst the end is not having any 1 plus I, right? So that's the only difference between the annuity beginning and then annuity end. Okay, that is it. All right. So these are the formulas, present value and the future value. So you need to, these formulas must be on your fingertips, right? It's not difficult. You can see that the difference between the 1 plus I and which is the present value and the future value is that with the future value, the one in bracket, the future value is not having any divided by 1 plus I exponent n, but then the present value is having that. It's having the 1 plus I 1 plus I exponent n divided by another 1 plus y exponent n, right? So get a difference. It's not difficult. All right. So let's take some examples. Let's take some examples. Let's take some examples. All right. So example. Araba invested. Example, Araba invested 500 cedis each year at the rate of 10%. At a rate of 10% for 5 years. At a rate of 10% for 5 years. How much will she earn? How much will she earn at the end of the 5th year? At the end of the 5th year, if she invested the amount at A, the beginning of the year, B, end of the year. Right. So this is the question. The question is that Araba invested 500 cedis each year at a rate of 10%. So what makes this question an annuity question? This each year makes it an annuity question. Each year makes this question an annuity question because you are investing at a regular interval, right? At a regular, every year you are investing. And how much are you investing? You are investing 500 cedis each year. So that is an annuity where you are making a uniform cash flow. A uniform cash flow, right? That is a uniform cash flow. You are investing every year, each year. So the each year makes it an annuity question. Each year, take note, the each year makes it what? An annuity. All right. So at the beginning and then at the end. So now the next question is to ask us, we know it is an annuity question. So we are going to use the annuity present value or the annuity future value. Right? The annuity present value or the annuity future value. Know that the present value of a single cash flow and the present value of a future cash flow, they are different from the annuity. Annuity is when you are making a constant cash flow, uniform cash flow within equal intervals, right? Yes. So now each year makes it annuity. The each year makes it what? An annuity. Annuity. So the next question is to ask ourselves whether we are going to use the present value formula or the future value formula. We have present value of annuity, we have future value of annuity. So which of them are we going to use? So that is where the next question that we ask ourselves. That's the next question that we ask ourselves. So how much will she earn at the end of the 5th year? At the end. So what comes to mind? You can see that future value comes to mind. You want the future value. How much will she earn at the end of the 5th year? That is a future value something, right? So we are going to use the future value. Now the future value, we have the future value ordinary and then the future value was due or advance. So the question is saying A, beginning. The beginning is the what? Is the advance. The beginning is the what? Is the advance. Annuity due or annuity advance. And then the end is the what? Ordinary annuity. Ordinary what? Annuity. So let's do the beginning. A. So the A at the beginning. So at the beginning, what is the future value? We know we have established that we are using the future value. So future value of annuity A over I bracket 1 plus I n minus 1. But then the question is saying beginning. So we are going to add the beginning interest 1 plus I, right? We are going to add the beginning interest 1 plus I. 1 plus I. All right. So what is the equal amount? The A here represents the equal payment. Equal amount, the equal amount that you are receiving or you are paying, that is the A. And the I is the interest rate. The interest rate, right? And the N is the number of years or the number of period, the period. Let me say the period. Right? So that is it. So now, what is the A equal payment? The equal payment is 500 cedis. You are investing 500 cedis each year. So the 500 is each is the equal amount that you are investing. So 500 over the interest rate, we give an interest rate of 10%. So 10% is 0.10, right? Then we have 1 plus 0.10 exponent n. What is the number of periods? For how many years? 5 years. For 5 years. So the 5 years, then minus 1. Brackets close 1 plus 0.10. So what are we getting? All right, so from my calculator, I'm getting 3357.81. 3357.81. That is the beginning balance. Then B is thinking about the future value at the end, ordinary. That is A over I into bracket 1 plus I n minus 1. There is no 1 plus I because it's an n. Because it's an n, right? The ordinary annuity. Alright, so 500 over the 0.10, then 1 plus 0.10. Number of years is 5 minus 1. So what do you have? So from my I'm getting 3052.55. You can't get actually on the screen. But if you try to do something, any bracket, you bring every bracket, you bring this bigger bracket, you bring this small bracket, everything must be inserted, right? Before you can get this answer. All right, so let's take another example. Let's take another example quickly. So that is example 2. Example 2. Example 2. Kofi needs 20,000 cedis. Kofi needs 20,000 cedis at the end of 3 years. At the end of 3 years to buy to buy an iPhone. Kofi needs 20,000 cedis at the end of 3 years to buy an iPhone. How much must he invest at the end of each year at the rate of 20%, at the rate of 20%, right? So this is a good question. Question is asking us, Kofi needs 20,000 at the end of 3 years. So what is this? What is the 20,000? The 20,000 is a future value. Kofi needs the 20,000 in 3 years' time, not now. Kofi needs the 20,000 when? In 3 years' time, at the end of the 3 years, to buy an iPhone. So this is the future value, because Kofi needs it in 3 years' time, at the end of 3 years, to buy an iPhone, right? Then at an interest rate of what? Interest rate of 20%. At number of period is what? 3 years. 3 years, right? And then how much they're asking us, how much must he invest at the end of each year? So they are asking of the equal amount. How much must he invest? How much must he be putting in the fund? Every time, every year, how much must he invest at the end of each year? Every year, how much must Kofi invest? That is the equal amount. So now here they are asking us of the equal amount. So using the future value, and now the question is saying at the end of each year, at the end. So what comes in mind? Future value ordinary, right? Future value ordinary annuity. Because it said at the end of the what period. It didn't say at the beginning. We would have used the annuity due or the annuity advance, but it said annuity at the end. So we take note of the keywords, right? Take note of the keywords in the question. So here the future value is A over I, 1 plus I, n minus 1, right? N minus 1. There is no 1 plus I because it is at the end of the word of the period. So now we want to make this A the subject because that is what we want to find. So making A the subject, this F thing will multiply the I. We multiply everywhere we see, we multiply through by I. So times I times I times I times I. So this will give us A into bracket 1 plus I exponent n minus 1. Then so this I will cancel this I. Then we are left with this, right? Because you are multiplying through by I. So this I will cancel this I. And then we'll be left with 𝑀𝑉 times I. 𝑀𝑉 times what? I. Alright. So we have something like this. So having something like this, what do? You want to make A the subject. Means you are going to divide both sides by 1 plus I exponent n minus 1. Then divide here too by 1 plus I exponent n minus 1. Right? So this will cancel this. So what is our A? Our A then becomes the future value times the interest all over to bracket 1 plus I n minus 1. N minus 1, right? So our A is this, right? This is our A. This is our what? Our A. This is our A. So from here we can just insert the figures. We can just insert the figures, which is what is the future value? 20,000 times the interest 20%, so 0.20. 1 plus 0.20. Number of years is 3 years minus 1. So what do we have? What is our A? Our A, according to my calculator, is 549.51. 549.51. Right? So don't be confused as to whether the question is asking. This question is not asking the present value. How much will she invest? Present value. No, it's asking the A. To take note, this is not action of the present value, right? It is not as how much will you invest at the end. At the end of each year. That is not the present value. That is the equal amount that you pay within the equal interval, right? So the A is the equal amount. All right. So let's look at another question too. Let's try more questions so that we become more familiar with what you are doing. Okay. So I'm continuing the question, example 3 here. So example 3. Example 3. Example 3 is Kukwa is investing 200 cedis every month. Kukwa is investing 200 cedis every month for 10 years. For 10 years. For 10 years. At a rate of 12%. Calculate how much she would have. Calculate how much she would have in the fund. At the end of the 10 years. So now the first question to ask yourself is it an annuity question? Is it an annuity question? What makes it an annuity question? So Kukwa is investing 200 cedis every month. That makes it an annuity. Every month. Every month you are making equal payments or you are receiving equal payment within equal intervals, right? So every month Kukwa is investing 200 cedis. That is an annuity. Once it changes from 200 cedis to let's say 300 cedis, it ceases to be annuity, right? Because annuity, the cash flow is constant. 200 cedis every month. Once it changes, it ceases to be an annuity, right? So I'm giving, let's say 5 years, and then for 3 years, 200 cedis, and then the last 3 years, it changes to 300 cedis. The annuity part will just be for 3 years. The annuity part will just be forward for the 3 years, because that is where we have the equal payment, equal 200. Once it changes to 300, then it means that it is not an annuity, right? So what makes it an annuity is that investing 200 every month, right, for 10 years. Every year, so every month we are 200, for 10 years. That is an annuity, right? So we have established that it is an annuity. The second question that we ask ourselves is, what is the question demanded? Calculate how much you will have in the fund at the end of the 10 years. So the next question to ask ourselves is it future value or the present value that the question is asking? Is the question asking for future value or present value? So from this one, it says how much you will have in the fund at the end of 10 years. So what comes in mind? Future value. Because at the end, future, not now, right? So future value. So we've established that it is an annuity and then it is future value. What is the next question? The next question to ask ourselves is the multiple compounding. I think in our first discussion, we talked about multiple compounding or frequency, where we said that the multiple compounding is where interest is flowing more than once, where interest on an investment is earned more than once in a year, right? Interest on an investment is earned more than once in a year. Where we are saying that for we can have monthly. Monthly is how many months we have? How many months? We have 12 months. 12 months. Then we have quarterly. How many quarters do we have in a year? We have 4, right? Then we talk of weekly. How many weeks do we have in a year? 52, right? 52 weeks. Then we talk of semi-annually. 2 semi-annual, right? Right, yes. So we are saying that when the question, all the interest rates given in the question are annual interest rates. Interest rates given in the question are for the whole year. So here we have 12%. This 12% given is for the entire period, right? It's for the entire period. Anytime they give you interest rate, it's for the, unless the question states that this interest rate is for a month. But all interest rates given is for a year, right? So once they are making this one the payment, or they are making an investment every month, means you have to adjust this interest to suit the monthly interest rate, right? To suit the monthly, because this interest rate is for the whole year, right? And then the number of periods must also change, but this is for years. If you want to convert it to months, how many months will we have? Converting 10 years to months, what will we get? Yes. So that is what we are supposed to do. So here, assuming it's that investing every year, that means there would not be any instance of multiple compounding or the frequency. So multiple compounding. So multiple compounding, I say that it is where the interest on an investment is earned more than once, right? You are earning interest more than once. So because it's more than one, so that the example is the weekly, the monthly, the semi-annually, and the quarterly that I talked about. Yes. So with this question, it is monthly. How many months? 12 months. It means anytime we see I in the question, interest rate I, the interest rate given is for the whole year. If you want it in months, we divide by 12 months, right? And then the number of period is in years. So we want the months. You are going to multiply it by what? By 12 months, if it is monthly. Assuming it is quarterly, that means you are going to divide by what? I divided by 4. Then the N2 will be multiplied by 4. So wherever we see I, we divide by the frequency or the multiple compounding. And then wherever we see N, we multiply by the multiple frequency. Right? Yes. So now that is how it is. So now let's solve this question. Let's solve this question. So this question is saying 𝑀𝒂𝒂 is investing 260 every month. That is monthly. Every month. It's an annuity, and we have established that you are using the future value, and also it is a multiple compounding. It is a multiple compounding question. It is a multiple compounding question. It is a multiple compounding question. So as you are watching, remember to subscribe to the channel, right? So that you'll be able to upload more videos. Because if you refuse to subscribe to the channel and then like and comment, it will not boost us, or it will not encourage us to do more videos. But once you subscribe to the channel and like, comment about this video, then we will be able to continue with more videos, right? Yes. So now let's continue. The future value is A over I. So this one is at the end or at the beginning. All right, it's at the end. And let me add this. Anytime the question is silent, whether it is at the end or at the beginning, it is assumed to be at the end. Anytime the question is silent, whether the question is not clear as to whether the investment is at the beginning or at the end, always use the at the end formula. So you ignore the 1 plus I that is attached to the general formula, right? All right. So that is it. So with this one, it's stated clearly that it is at the end, right? At the end of the 10 years. So we have the 1 plus I, then n, then minus 1. Now, because of the multiple compound, we say that anytime we see I, they are going to divide. So we have to adjust this formula. I want to adjust this formula. So wherever I see I divide by the multiple compounding, I divide. And then whenever I see n, I multiply. So I'm adjusting this formula because of the multiple compounding effect. Every month, assuming it is every year, I would have maintained my general formula. But it is a multiple compounding. But the interest rate given was in years. You have to adjust it. So now, in order to make my work simple, I would even adjust it before I insert it because to make it. But then you can also work with it. You can just punch everything on your calculator and get it. But if you're not careful, you might get it wrong. So let me get my I. So my I, the interest rate is, what is the interest rate given? 12%. 12% is 0.12 all over the multiple compound 12 months. What do I have? 0.12 divided by 4. So that's giving me 0.01. So 0.01. And then my number of period would also be that would be the how many years? 10 years times the 12 months, giving us 120, right? Giving us the 120. So from here I can just proceed. And have my A. What is my A? My A is how much? 200 cedis. 200 cedis. Right? So 200. 200 over I over M. What did I get? I had 0.01. Then into bracket 1 plus I over M. I had 0.01. Number of period I had 120 minus 1. Right. So now, what is final answer? So according to my calculator, getting 46007.74. 0.74. All right. So now that is good. Let's take more example. Another example. Let's take another example so that you'll be exposed with how it works. You know all the tricks. All right. So example 4. All right. So let's say Princess took a loan. Princess took a loan of 20,000 cedis for her 𝑭𝒊𝒏𝒂𝒏𝒄𝒊𝒂𝒍 business. Took a loan of 20,000 for a 𝑭𝒊𝒏𝒂𝒏𝒄𝒊𝒂𝒍 business at at the rate at the rate of 15%. At the rate of 15% for 4 years. For 4 years. Calculate how much she would pay. Calculate how much she would pay each year, how much you pay each year. Calculate how much you pay each year in order to pay the full loan and interest. In order to pay the full loan and what and interest in 4 years time. In 4 years time, right? Right. So I think that Princess took a loan for a solo business, right? So the first question is it an annuity question? What makes it an annuity question? Okay, so Princess took a loan. Calculate how much you pay for each year. So the each year here means annuity, right? Each year annuity. We've established that it is an annuity question. Okay, good. Now, whether it is a present value or future value is the next question. Are we going to focus on present value or we are going to focus on the future value? The question is we should calculate how much you pay. So the question is basically asking of the A, right? How much you pay each year. That is the A, equal amount each year. A, that is the A. Yes, but is the A for the present value or A for future value? Is it future value A or present value A? Now, Princess took a loan. When do you take a loan? You are taking the loan now. You are taking the loan what? Now. So it is the present value. You are taking the loan now. The loan is taken now. So if you are taking the loan now, then it is the present value. I'm going to the bank to take a loan. It is the present value. How much is the loan? 20,000 cents. So that is the present value. So present value is equal to 20,000. That is the loan that I'm going to take. 20,000. 20,000. Right? Number of period is what? It's 4 years. Then the interest rate is 15%. What is my A? I don't know. That is what the question is requiring. Calculate how much she would pay each year. That is the annuity. So you are going to see the present value of annuity. Now, the question mentioned that at the end or at the beginning, the rate of 15%. Calculate how much you would pay each year in order to pay the full. See, this question is silent. Now, when the question is silent, that is why I said that assume that it is at the end, right? Assume that it is what at the end. Assume it is at the end. Assume it is at the end, right? So now, let's use our present value. Present value is equal to A over I. And the next question is whether it is a multiple compounding. Is it a multiple compounding? Let's took a loading time for example at the rate of 15% for 4 years. Calculate how much you pay each year. How much you pay what each year. So is it a multiple compounding? No, it is not a multiple compounding because it is each year, right? Not every month, every quarter, weekly, or semi-annually. Or annually. So now you have 1 plus I n minus 1 all over the same 1 plus I n. It's not difficult. So what is our A? Yes, you are making A the subject. What do? You cross multiply. You multiply through by I. I will multiply PV. I will multiply this one too. So this I will cancel this I, and you'll be left with the PV times I. So basically our A is equal to PV times I all over. Then you divide through. So this is 1 plus I n minus 1 all over 1 plus I n. Right? Okay. So from here, what is our A? A is equal to 20,000 times the interest rate of 0.15 all over the 1 plus the 0.15. What is the number? Is 4 years, right? Minus 1 all over 1 plus 0.15, 4 years, bracket close. So what do we have? So according to my calculator, A is 7005.31 cedis. 31 cedis. 31 cedis. Alright. Okay, so let's solve the last question, then we end here. Let's solve the last question, then we end here. So last question will be example 5, which is what is the present value? What is the present value of 5,000 cedis paid each year? What is the present value of 5,000 cedis paid each quarter? Let me say each quarter. Let me say each quarter. So each quarter. At the rate of 12% for 3 years. Here, the question is specific. What is the present value? We are going to use the present value. 5,000 each quarter. So then I need this. I need because they are paying every quarter. They are paying 5,000. So that's a uniform cash flow. So that's an annuity. Right now, we know it is an annuity, and then we know it is the present value. So that's what the question is asking. The next question is whether it's a multiple compounded. Yes, it's a multiple compounded. Why? Because the each quarter. So each quarter, every month, each quarter, every month, weekly, semi-annually. They are all multiple compounded. So because of the each quarter, assuming it's each year, then it is not a multiple compounded, but it is each quarter, so it is a multiple compounded. It is a multiple compounded. So now we have established that. So we are using the present value. Present value. So what is our A? Our A is 5,000. What is the present value of 5,000 paid each year? So A is 5,000. I is 12%. And N is 3 years. And then the multiple compounding is quarters. How many quarters do we have? We have 4 quarters. So 4 quarters. 4 quarters in a year, right? So the present value is the A over I. Then we have the 1 plus I n minus 1 all over 1 plus I n. Is it at the beginning or at the end? The question did not state. So what do? We assume it is at the end. Therefore, you are not going to bring the 1 plus I. You are not going to bring the 1 plus I. Now, what is the present value? 5,000 all over there. So for our work to be simple, I usually want to find the I, which is the I divided by the M. So the multiple compounding, we are going to divide by M, right? Wherever we see I, and then M, we multiply by M. Wherever we see I, we divide by M, and then N, we multiply by M. That is why wherever I see M, N, I multiply by M. Wherever I see I divide by M. So what is the I? The I is 12%. So 12% is given as 0.12 divided by how many quarters? 4 quarters. And that is given as 0.12 divided by 4 quarters. What do you have? 0.03. 0.03, right? And then the n is giving us what? N is 3 years times 4, giving us 12. So from here we can get our I 0.03, and then 1 plus 0.03, number is 12 minus 1, all over 1 plus 0.03, n is what? 12. So what is the answer? So according to my calculator, I'm getting 49770.202. So this is where what I'm getting. So thank you very much for watching this video. Make sure you like, you subscribe, and then you comment at the comment section so that it would encourage us to upload more videos. Once you don't subscribe to the channel, you don't comment, you don't like, then it means you are stopping us from uploading more videos. Thank you very much and have a wonderful day.